final presenter in this part of the session is Juha Schweighofer. I hope I've got that pronunciation right. Who's the senior expert for ship technology via Donau, Austria. And he's going to talk about the MOWE IT project, a handbook on climate change adaptation for inland waterway transport. Juha has an MSc and a doctorate in technology and naval architecture from the Helsinki University of Technology. And he acted there finally as senior research scientist. And since 2006, he's been employed as a senior expert by Via Donau, the Austrian waterway management company dealing with projects and consultancy related to ship technology as well as climate change. Juha, welcome to the podium.
Mr. Chairman, ladies and gentlemen, good morning. If we say yes to inland waterway transport, then we have also to say yes to climate change adaptation. MOWE IT means management of weather events in the transport system. It was a project funded by the 7th Framework Program of the European Union with the objective to identify existing best practices and to develop methodologies to mitigate the impact of natural disasters and extreme weather phenomena on the transport system performance of the European Union. The main outcome of this project was the delivery of mode-specific adaptation guidebooks for rail, road, aviation, inland waterway transport and maritime transport. Via Donau created the adaptation handbook for inland waterway transport. As already mentioned yesterday, inland waterway transport plays a significant role for the economy of the European Union. The inland waterways in Europe account for 40,000 kilometers. The transport performance in 2014 was 150 billion ton kilometers. The most significant inland waterway corridor is the Rhine corridor, being highlighted here. The inland waterway fleet in the European Union comprises around 12,000 motorized units. The research carried out in the MOWE IT project was limited to the Rhine corridor and the Danube corridor being in the southeast of Europe. Weather events of relevance to inland waterway transport are drought causing low water, thereby causing limited cargo carrying capacity of vessels, precipitation and snowmelt causing high water and floods, leading to suspension of navigation and damage to the waterway infrastructure, low temperatures leading to the formation of ice in some cases, leading thereby to suspension of navigation and also damage to waterway installations like buoys. Of less importance are fog, leading to reduced visibility, delays in waterway operations, and wind, leading to increased forces acting on vessels, causing difficulties in maneuverability of the vessels. In the past, several projects have been carried out dealing with different climate change projections till 2050, till 2100. In order to name a few of these projects, the EcoNet project, the Event project, the comprehensive program CLIVAS in Germany. All of these projects arrive at one conclusion. that for the Rhine-Main-Danube corridor, we do not expect any decrease in the performance of inland waterway transport due to climate change. It does not mean that we have now no problem. It means that we have the problem, and the problem is already present now. In order to cope with the impact of extreme weather events on inland waterway transport now and in the future, different measures can be taken. And the overall goal in taking these measures is to improve the economic performance and competitiveness of inland waterway transport in general, and in particular when an extreme weather event occurs. The first measure is the continuous observation of climate change impacts on inland waterway transport. It serves first the validation of the model outcomes, and second, the development of better models for better predictions of impacts of climate change on inland waterway transport. And finally, observation of climate change impacts on infrastructure installations carried out now will give you information on the proper working of these installations. According to my opinion, the most significant adaptation measure to be taken relates to the adaptation of the infrastructure. And the goal is to create an infrastructure which agrees to the recommended fairway parameters as laid down in the AGN. The first measure to be taken is proper maintenance of the infrastructure, which means surveying, dredging, surveying again, and providing a full information to the ship owner in order to utilize the waterway in the best way. Second, river engineering works can be also considered, like installation of groins or draining walls. If we think about extension of existing inland waterways or removal of infrastructural bottlenecks requiring more comprehensive river engineering works, then sustainable waterway planning is the key to do so. The main aspects of inland waterway infrastructure development are: you have to take into account the economics of inland waterway transport, but you have to take also into account the ecological effects of the works you are going to do. This can be done by an integrative approach, which means all stakeholders involved in the waterway have to be involved also in the planning process. Information and communication technology plays a very significant role in providing full information on the waterway to the ship owner. Here, information to be provided comprises forecasts of water depth, most efficient route of navigation, for example, fairway in the fairway, then accurate real-time information about the fairway conditions, which should involve also full information derived by multi-beam measurements on shallow water sections, so that you can utilize the fairway in the best way, and information on time of arrival, for example, waiting times at locks, bridges, and so on. If climate change takes place, the waterway conditions are changing, then of course the vessels can be also modified. This is a very difficult topic, and the key in adapting the waterway fleet is that any modernization measure has to be technically feasible, but it has to be also economically feasible. It makes no sense to create a shallow water vessel which is sailing most of the time in deep water and being less competitive in comparison to existing vessels. Ports. In the European Union, we have around 1,500 inland ports. And then these ports, they will face the changing water levels. They will also face modernized vessels, which means they have to deal with the weather phenomena and new vessel types. And these vessel types, they will be operated in a continuous operation, which means that one of the most important adaptation measures is the adaptation of working hours. This means that the ports have to work also in a continuous operating mode. In addition, provision of berth anchorages and shore equipment, vertical quays, fairway maintenance, upgrade of transshipment facilities, increase of storage facilities, and adequate fendering systems can be thought of. Inland waterway transport is an international business. This means if many countries are involved, if one country is not doing his job properly, then all the other countries will suffer. This means that we need also a cooperation between the waterway administrations for provision of standardized information on the navigation conditions to the shipping companies. In addition, also cooperation of river commissions is recommended in order to have a common regulative framework in the European Union, but also in order to speak with one voice in direction of the European Union. Finally, logistics is a part of inland waterway transport, or inland waterway transport is a part of logistics. This means that here also adaptation strategies can be carried out. These comprise development of risk strategies, investment in additional storage capacity, and cooperation with other modes of transport. We have now considered several adaptation measures, and if we go to the ship owner, if we go to the logistics provider, then they say actually, why should we adapt? It is actually your responsibility as infrastructure provider to provide also a proper working infrastructure. And this is where we start. If you have a good infrastructure and negative impacts due to climate change, then the infrastructure will become bad. If you have a bad infrastructure and you have negative climate change impacts, then this will lead to collapse of the transport system. Therefore, I would recommend also to start with adaptation measures in the area of infrastructure adaptation, which means the implementation of the TEN-T priority projects, carrying out improved maintenance, using the cycle surveying, dredging, and provision of full information to the ship owner, realization of river engineering works like installation of groins, training walls, based on the continuous observation of their proper functioning. And all these measures have to be taken always in mind that we have to consider the impacts on the environment. We have to try to find an integrative approach where economy of shipping and ecology reaches a balance. If we say navigare necesse est, then we have to say also adaptation necesse est. Thank you.